Thanks very much. This is sort of a, you're standing up here, that's a recipe for everything breaking. Yeah, now I'm not working, so we'll just have to see how this all goes. Okay, I was a little bit thinking about what Nick mentioned yesterday about the life cycle of CCTBX and where everything sits, so thought I'd just do a similar thing here, remind you of what we're doing here with the Cheetah side of things, the Cheetah and BioXFEL life cycle, which is slightly different to CCTBX. You've got the experiment, you've got your online monitoring, and then at Slack, this is using Slack, using the PSANA framework that Chris just talked about, we do our data reduction, and that produces a set of files that are facility independent, and then BioXFEL and all of this can operate completely independently of the PSANA framework. So you can do your data reduction. What we usually do our data reduction here before we come to the end of the experiment even, or if we go back to the data, we do all that within the Slack framework. There was a time early on when the frameworks weren't as good as they are now, and we actually took all of the hundreds of terabytes home and worked on it at home. These days things are good enough at Slack, including pulling old experiments from tape. For example, the boot A data, just a couple of clicks and the data comes back from the tape system and magically appears. We do all of this data reduction at Slack, generate the reduced data set, ship that home, and then this all operates outside of the framework, giving us a little bit more flexibility, no need to use virtual boxes and etc. for doing this indexing and integration step. So that's just a slightly different philosophy that we adopted, and it all operates there. So I think after Chris's talk, most of you have probably sorted out these sides of things. You need to be able to log into Slack, okay? You need to be able to get to the experiment. Most of you, experiment data, most of you should probably have checked out that that works already. You need to be able to mess around in the scratch space. All of this is associated with the permissions for the experiment that hopefully have been managed nicely. Should be able to submit a job to the batch queue. This B sub minus Q, PSANA queue, host name or ls. Chris showed you that command yesterday. If this doesn't work when you press the buttons in Cheetah to submit a job to the batch queue, it'll complain at you and tell you to go away. If you can't create the data, it'll complain at you and say, I can't do anything, I don't have the permissions. And of course, if you can't get at the data, you're screwed. And this actually is one of the interesting things when you go and do an experiment, because the only person, there's two people who can actually give you access to the data. One is the uber gods of beamline scientists who have access and power to do everything. But they don't actually do that most of the time, because it's up to the PI to go and add people's Unix accounts to the experiment, which gives them access to the online logbook, gives them access to the data, gives them access to the all of those sorts of things. And by default, the PI of the experiment can do all of those things because they are the gods, so they conveniently forget that everyone else needs to have this access granted to them. And so you usually come to the experiments, oh yeah, you need access, you need access. You can sort it out before. It's really easy on the web to do, but if you can't get at the data, you're screwed. Hopefully all of that works. And behind all of Cheetah, which is really just a front-end GUI, there's this thing which submits jobs to the batch farm and goes off and processes things. And just the other day, they rearranged the batch farms around. This happens periodically. You get used to a changing ecosystem. They've even shifted the location. Some of the compute nodes are now in a different building. So the way I've set up the tutorial is to actually use this PSANA queue. It runs on the data stored on the big spinning disk arrays. It can see all of the data going back into whatever history is stored on there. And the reason I picked to analyze on that is its throughput to the disks is somewhat higher, so you're less likely to get I/O bound. If you're running any near haul, far haul, that's XPP or CXI, the data is saved, first of all, on these fast feedback buffers, which is RAID arrays of solid-state disk drives. From there, it is shipped off to the main spinning disk, so you actually see it on these fast feedback nodes a bit quicker. If you're running down there, you might want to use the PSFEHQ or the PSNEHQ to submit your jobs to instead. And if you're doing compute-intensive stuff, you can get 1,700 cores here. But what worried me about that is, it's nice machines, but the bandwidth through to the data didn't seem quite so good. So lurking behind PS login, it's sort of like choose your own, it's like one of these dungeon master type games. You walk in through PS login and you find your way around, and you find your way to PS Anna, which logs you onto some nodes that see all the data, and then you can submit jobs to all of these things, and there's PS exports for taking the data home. If you've got jobs that you really don't care about, there are these idle queues. Nodes are limited, so a nasty thing to do someone is you notice your competitor's doing an experiment, so you launch a big compute job the day the experiment starts, shoots up all the resources. Yeah, we try to avoid that sort of thing as much as possible. But you kind of end up finding your way around this background here. Cheetah's a PSANA module. So Chris talked about PSANA and all the things it can do. Yeah, and they started developing that in 2011 sometime, and 2011 is when we hit the CSPAT detector in big force, and we started working on our own frameworks there because we simply had to. But it's basically a PSANA module, and so you need these same things that Chris talked about, this ANA-env.sh and the sit setup, need to be executed for PSANA to function. Without that, you'll get cryptic things. It'll call some of the Python bindings and things and say, I can't find the experiment database, and weird errors. So you need to be set up for that sort of thing, but Chris has taken care of that. So then there was the question of what to do for the tutorial here, and I am going to take a couple of minutes just to whisk you through what I think you'd want to do here. The idea was to give you a template and something to start with that you can get up and running fairly quickly. And then based on that, most people looking at the templates will be able to figure out what to change for their own experiments pretty quickly, rather than going through the tedious steps. So no need to write this down. I'll go back over these steps. First thing is how to connect. Simple and brain dead is the SSH-X. It does standard X forwarding, but the graphical feedback can be a little bit glacial. Faster graphics, but more complex, you can either use the VNC server or the No machine. For this tutorial, I wouldn't bother spending more than 3 minutes trying to set that up. If you know how to do it, great. You'll get much better feedback. Your graphics will come up much quicker. I can run this from Hamburg and it's responsive enough. If I try running the first one, it's click a button and make a cup of tea. So as Chris mentioned, using this virtual screen servers is really good because there's graphical interface. Then I created a couple of template things. There's a series of files, a series of structures that you need. We'll get into this later. Unpack those things. Pick your data set, probably Carol's last time. That's the one I tested. I actually didn't test this one. I grabbed something that I used ages ago. Then you need to change 2 files to tell you where the data is. They'll be inside whatever directory you pull it out to a GUI crawler.config. This tells the front-end GUI where to look for the files, where the XTCs are, where the HDF5 files are. There's one line to change there, and then there's another script that launches all the batch jobs, and you need to change 2 lines there. I'll get to that. Don't need to do that right now. Then Cheetah's centrally installed. You need to just source one of these setup.csh things. It just says, OK, point to these standard locations. I deliberately didn't do any upgrades since our last experiment, because it was about to break for this tutorial. But this I keep maintained with generally the latest updates. So when they change something in the DAC, I update this central version, and then that means you're generally up to date. And then you start the crawler, simple command. It launches into a programming environment that I learned ages ago. Not even Python. It was originally written for the PDP-11. So it's a bit text-based, but it works. And it pulls up a little thing. Find the experiment. You go and navigate to your experiment, open up the crawler file, and you should come up with a GUI. Now what happens here? When you're running this crawler thing in the background, it's basically just updating a bunch of text files that it displays on this table. And if two people do that at the same time within the one directory space, you can end up with a bit of a race condition. So many people can view this table, view the data, but only one should be looking at should be controlling things at any time. And to avoid accidentally wiping your data, I may force you to go in and do this unlock command operations to be able to change anything, and then start the crawler, and it'll go and populate the table with all of the XTCs that you have. And then, because I wanted you to get going quickly, this is the gadolinium lysosome data. I did this up like 7 a.m. this morning before the talk. Really didn't take long. Pick a run, just type in the appropriate ini file that contains the configuration parameters, click OK, and it should go away and start processing. If everything's working fine, after a while you should get the hit rate, the resolution, saturation plots, virtual powder coming out of it, be able to view some of the hits, tweak the hit finding parameters up, change the ini files to change configurations, and then basically with a couple of clicks launch processing of all of the data. And now one comment from the Beamline scientists was when we're running and the data's coming in, the DAC keeps up quite nicely, and things fall in a heap when I hop on a plane because I've said, okay, let's reprocess all of the experimental data for the entire week in one go, and the batch farm gets loaded up. And now we're going to do this times however many copies. So I hope things work out. And then by the end of it, you should at least have a few runs processed. So that's what I'm going to work through. That's the idea. That to set you up with a bit of a template of how to get through all of that. And the question that I would like to ask now of you, there's two ways. Tom White had the very nice idea that I could just put these slides on an infinite loop playing over and you can work through at your own speed. Or I can sit up here and lead you all through hand by hand in lockstep. Would you rather be synchronous or asynchronous? Which way would you like to run this? Anyone got a preference?
How much time do we have?
Well, we've got about half an hour, 3/4 of an hour to try and get through this. So, question is, how you want to do this? Okay, then in that case, I'll just try and lead you through things. First thing is log yourself on like that. Is that everyone got themselves that far? Everyone's got themselves into the experiment space. Now, within the experiment space, you should have make dir your username or make dir something. Make your own little private space within there somehow. Okay. And within that little directory that you create, that is sort of going to be your private space, so you don't extract everything. So go and see if you can extract that file there, and it'll just pull out a bunch of standard configurations. In fact, in this directory here, there's a standard bare bones template that looks very much like this. This one I happen to have customized for this experiment, but a bare bones template that you can unpack and basically sets everything up. This is also described on the website. So that should create a directory called Cheetah. Inside that there'll be, I think it's 4 directories. There's one called GUI that basically contains the text files that this front end works on. There's process that contains the scripts and ini files. Then HDF5 where the results go, and a calib directory that contains things like dark pixel mask, bad pixel masks, geometry files, and the other things. They can be shared with BioXFEL as well. Okay? And once you're down in there, you just need to edit these 2 files. Okay. This you'll find in that directory that you just untarred, this GUI crawler.config file. It says XTC directory, that's where your XTC files should be located. Don't use the one there because that's from a different experiment. I think if I've done the template properly, that should actually already be set up to point to Carol's lysosome data. And then all you need to do, so that's standard for everyone. Everyone's looking at the same data, so that doesn't have to change. But your HDF5 directory, which is where you want to stick the output of Cheetah, you're going to have to add in here, it'll be experiment number, scratch, your username, Cheetah HDF5. So you sort of need to tell it where you add that one layer of where the data is located. Okay? And similarly over here, this is in the process script. This is actually just a script. You can launch it from the command line if you want to. It's process run number ini file tag. All the GUI does is call this script. Once again, I should have set up already where the XTC is, but you'll have to change these 2 things, the H5 dia and the config dia, to once again add this, your private little directory in there. I couldn't do that for everyone because it's all different. But you know, think of it this way. If you're coming in and you're trying to start a new experiment, you just copy this template over. You have to modify these two files, which are hopefully moderately self-explanatory, and then you're ready and up and running. If at the next step, when you try to run things, it says, I can't find HDF5 directories or errors, go back to these two scripts, and you'll probably find your errors located somewhere in there.
HDF5 DIRs should we use?
The
tarball.
Yeah, that's where the tarball was expanded. It'll be the scratch directory for this experiment, which I won't recite because I'll go mad, times whatever you called your private directory, and then there's a Cheetah thingy in there. You need to insert what your private directory thingy is in there. And of course, you could point it anywhere. You could do whatever. Okay? Now, too fast, too slow? Everyone got to that point? Yeah. How's that going? Is it too fast, too slow? Thumbs up? Thumbs up so far?
A little bit too fast.
Okay, a little bit too fast, that's fine. And actually, Nadia just mentioned if you need help, there's a couple of floaters who know what's going on. Just like with Jason, raise your hands and say, help ticket.
So what do you run speed out
in Scratch. Just in Scratch, like you'll see in the experiment Scratch directory, there's an Anton directory.
Right now I'm at the reg B, CXI.
CXI whatnot, then you need to go into the Scratch directory where you have writer permissions.
I don't.
You don't?
I think I don't.
That was that problem earlier. Can you touch a file in that space?
Yeah, I tried to. I don't.
Ah, okay.
But I expanded it in my home directory, if this is fine.
That should work. The problem with the home directory is it's not as fast a disk system, but it will work. And also there's a quota on that, so you can rapidly fill up your quota with experimental data.
Okay.
So it is actually better to use the Scratch directories in principle.
Of course.
That's a workaround. The thing is, if you can't actually write to the Scratch, you might not be able to see the data because those two permissions are linked.
Okay, so maybe someone wants to look.
Don't use this directory name, of course. It's Nadia's.
Yeah, of course.
Yeah, it's the one from this experiment. It's not that one. I put the wrong thing up.
But if you use the tarball that you listed,
Yeah.
it comes with the right numbers.
Yeah, right. Yeah. But there was a problem here. Couldn't create something in Scratch. Now you can't create things in the experiment directory, the CXI whatnot directory, because that's God's only. But in Scratch, you should be able to mess around.
So in the
like slash scratch
slash HDF5.
Yeah.
In our
like,
case, the tarball just attached to the Cheetah, so we
Yeah.
where they have their.
Or is that
No, you leave the Cheetah there. You just have to add your private.
right? But HDF5,
Yeah.
that directory does not exist in our
Tarball?
tarball.
Okay, then make HDF5. Yeah.
It should.
Yeah, it should. I might have copied and forgotten to create it somehow.
Because I just did it.
You just did it. Okay. Then maybe people are looking in slightly different spots.
Oh, I'm sorry, it is there.
Okay, that's okay. I did a bit of shenanigans copying things around so you got only the template and not all my processed data as well. Okay? How's it going so far? Is it people sort of there?
Can we test it to know we did it right?
What's that?
Is there something we can do to test it to make sure we try to do it right?
That's the next bit. Okay. Who still needs that previous slide of what to modify? Okay.
Sketches.
Okay. So then you source this. By the way, all of this is also on my website. On the website, it's basically
The Scratch is not slash Scratch, but you mean slash reg slash d slash ps
SDM / experiment what CXI experiment whatnot Scratch, and then
experiment.
within that you can do something.
Yeah,
Right.
then there any experiment there.
No, only this experiment.
Only the one that we.
Only the one that we have permission for.
Just
For this.
84914.
Yeah, 84914, whatever it is.
This may be also the problem.
Yeah. Hi, Chris. You have a.
Yeah, I just wanted to check.
So the instructions are on your website?
The instructions are also on my website. They're not. Yeah, they're not as experiment specific, but they're basically the same.
I did pretty much exactly what
What? If anyone happens to still be using Bash, then you just set up, you do the, whatever the Bash is, setup.sh. I don't, yeah, I personally don't test the SH thing as much, so I hope it works.
I don't have permission to scratch.
Okay, that's an experiment. Okay.
This is the one. Are we in the scratch? Yeah, I use that. It's just
okay, so you should be able to SSH minus X into PSANA here. These experiment names always confuse the hell out of me. Okay, so let me show you what I do here. I just changed tack a little bit and brought up an interactive window because it might actually help explain things here. So in my thing, I've been in a few experiments, so sorry about the colors. I can go into a 2014 directory, and in there I have links to all of the experiments. Okay, they're just symbolic links, so I can go into this. This is the tutorial one here, 6.84914, and I just create a bunch of links like this to make going around the world easier. Okay, and go into there. That's the Scratch. These colors are really awful. That's the Scratch directory. If I go down into Anton there, you'll see there's a Cheetah directory, and that's where you've got the GUI file, and that's where you've got the process files that I was just talking about, okay? That's what you should see down there. And all of this should be like, here I've got this Anton Cheetah thing, and if I were to GUI/caller.config, you can see here I've got HDF5 the experiment number, Scratch, and then I just inserted my username there, okay? So what do you do now? Okay, I can go back to my home directory. I've got an alias to this thing, but you basically source/reg g cfl. What's going on here? Let me look at that directory. /reg g cfl is actually a central installation of things. Reg g itself, it's a location of things. That's where CAS, CCTVX, etc. live. CFEL, we've got a directory in there for the software that we maintain, and there's CRISPFEL's standard installation in there, and there's also Cheetah's standard installation in there, and that's where you find this setup.csh, setup.sh templates, things, and these XFEL workshop things. So I just go source, setup.csh. I've of course created an alias for this to make it easier. Setting up Cheetah using the latest, blah, blah, blah. And now you should just be able to go cheetah-GUI and it'll launch things. Now this is this ideal environment that I use. It runs as a virtual machine. You don't need a license. It was originally written in the 70s, okay? And it's still going strong. Shows how up to date. Now, every time you select a new experiment, it actually goes into a little dot file. So there's the list of all the experiments that I've got just standard by default saved, and I can just click into that list. If you're doing this for the first time, of course, you won't have that list, so you'll have to go find a different experiment. And from here, you can just navigate to, you can type in here what the path is. or because I've got this alias set up just going to 2014, and then, which is just where I've set up my alias, down into here, down into Anton, which is now my private directory. This is where that tarball expanded to. Go into GUI and click on this crawler.config file that you modified. Okay? And it comes up with the status of what I processed just a little while ago. Okay, that's what I did this morning. And now, to make this run for yourself, you can do this unlock the command operations. So it's set up initially so that you can't run the crawler, you can't submit new jobs. The idea is it will set up in a safe mode where one button press won't delete all your data and reprocess it by accident. Okay? It's sort of set up. Now you can still view things, you can still click on all of this and view the data and do everything else, but it's set up by default to put you into a safe mode so that someone won't crap on it all over things. Unlock that. And then you start this little beast, which is really just a script that goes through, looks at the HDF5 files, the XTC files. Every minute it does that, and it updates things here. And of course, I have all of this data sitting here because I've got all of the directory. You will probably, at that point, end up with all of those going blank. Okay. How are we going so far? Is that so far so good? Okay. Now, if you want to process something, let me flip back to Keynote here. So we've just gone through this little bit, which hopefully is not too intimidating. And next time you launch the GUI, by the way, that experiment will come up in this dialog box, so you just have one click to go to that experiment, or any of the other experiments. So what's the next thing? Unlock command, we've done this. And you now have this, something like this. Let's say I want to process one of these runs. Now, in the interests of things actually running in a reasonable way, I created a couple of templates there to actually do your own thing. So you can click on a run, say run 9, like that. Then you can go run Cheetah. Pick this ini file, which sort of, to cut long things short, that specifies the way the Cheetah is going to run. Okay. If I bring now, let me see if I can bring somewhere X11 window. If I can bring this, that's not it. Window PS login. So this thing, you can see a little bit of text appearing here. If I click OK on this, it launches a bunch of stuff here. It says searching for XTCs, putting the HDF5 data here, moving to that directory, deleting your previous files, and then launching things. Hit find a job sent to the queue. Job whatnot is sent to the PS Anna batch queue, and so on. What you find is that this is already noted. The job has been submitted. Okay, so its status here has changed automatically to submitted. If I refresh here and refresh there, now it's started. What's actually going on there? If I bring up another window, PS login, bring this over here, I can do B jobs minus U all minus Q, PS Anna Q. They're all the jobs running on PS Anna, and who the hell is Sitcourse is running something? Anyway, here's the job. It's running on PS Anna 1406, running here, launched from this PS Anna node, and it's running in the background on the batch farm already. Okay? Yeah.
There's a bit of confusion about what Scratch directory is for.
How about you clarify that? It's more your... You tell them the party line.
Okay.
I told one guy down the front here.
Chris. Maybe Chris is better.
Okay, just so you know what we're talking about up here, there's apparently confusion. You have a home directory where you save things, and there's the experiment Scratch directory. Your home directory is on slower disks and has a quota. If you process data there, you're going to clog things up and wonder why, you know, it's like living in a small apartment and buying a lot of furniture. It ain't going to work. Okay. So data processed from the experiment should really go in Scratch. I think that's the message, isn't it, Jason? Jason might say it a bit better.
So basically, when Anton was setting this up...
Feel free to type on there if you want to show people around what's different.
Okay. So you were asking people to put in their home directory.
In Scratch.
No, the configuration stuff.
Okay.
When you did the tar.
I actually expected people to put that in the experiment Scratch.
That goes. So maybe you just explain this. But then also when people were editing the process and putting their home directory instead of Scratch.
Yeah.
Everything stays in Scratch.
Yeah, it's
Okay.
Because I didn't know what you said, so I was helping some things out, and I'm a little bit confused. But I know that there's more confusion, so just explain again.
So the point of confusion that's going on here is if I go in PSANA here and I print this, you start off in your home directory, okay? You start off in a home directory like this, and this is a nice little bit of small space that you can see from any nodes and things. It's not where you should put analysis results, okay? Where you should really be putting the analysis is in, what's the experiment number? It's 84914. You should really be doing something like cd/reg, d psdm cxi cxi 84914. Okay, that's the experiment directory on the faster disk systems, and you should go into Scratch there and be putting all of the output from the experiments in this Scratch directory, not in your home directory. Little bits of data in home is fine, but once you start processing this volume of data, you're just going to overrun it. That's what this Scratch space is for. Okay, so this output should all be going in there. How's this going? If I have a look here, it's saying it started. It's still saying that. It hasn't got to its first checkpoint, so things might be a little bit slow on the batch farm at the moment. Okay.
We're just going to change the process file.
Okay. So things should be running there. Unfortunately for this one, the hit rate is a bit low for the first little bit, so you mightn't see things popping up quite immediately.
Yeah, as well as the
Okay.
But I might have changed it. I changed my
yes, the other one I.
Okay. So everyone, I can see quite a few people here have got it running already. Someone's run 1.2, and a bunch of people here running 1.9. So all of these guys are running in parallel on the, Normally you try not to do this, you just have one process in the data, but this is great for the tutorial, so a few people have got that sort of thing to work. Okay. So if your jobs are appearing in here, and that's just this command, then you know things are working. Okay, and you can click refresh. And now, once it gets to its first checkpoint at 1,000 files, it says, okay, I'm more than started, I've not finished, but I haven't found any hits yet. If I go over to the, that sort of doesn't surprise me, because if I go over to the experiment, it actually starts off with a very low hit rate, this data set, so you won't get instant gratification. But once it runs, you should be able to come out with that sort of thing pretty quickly. Okay, and let's just to skip ahead and show you some other things here. Let's say you want to have a look at the data from this one. You just go up here, view hits, click on that button. For most of you, that won't work until you've actually generated some hits, so I'll just run ahead and show you what it is. It's a tad slow here. Comes up with the GUI, and you click on this crystal's default crystal display settings, which puts it into something that circles the peaks. Hello, are you going to do this? This is the problem with running X11, okay? And it looks like that, with the peaks that Cheetah has found circled in this way. And then, crystallographers like looking at their data, so you just click along. When you're at Slack, this feedback works a lot quicker. The entire latency here is just because I did SSH minus X. And that. And you just go for random images here, it tells you which image it is, title up here is which image it is. And you can just flick through and see what your data is doing and seeing what the peak finding is like, whether it's coming up with decent things. And it's amazing. Crystallographers really like to look at their data. They can look at this and immediately tell whether the spot finding's good, whether the crystals are mosaic, roughly what the resolution is. And just by flipping through images semi-randomly, you can just go shuffle here if you want to, and it'll sit there. If you're at Slack where it's fast, it'll be a new image every second, and you can just sit there and watch your data go past. Okay, this is the hit found stuff, and you just watch it and have a look at what your crystal hits look like with the peaks circled, so you can see how your peak finding's going and everything. And it will just sit there and continually update and update and update that for you. So it's missing a couple of peaks. You can see here. The question is whether it's worth changing the peak finding settings or if this is okay. What you can then do, I'll just wait for this to stop. It's actually something in here. I re-implemented the peak finder that's in Cheetah within the GUI. So what you can do is you can say, now this at the moment is circling the peaks that were found by Cheetah running on the batch node. You can switch it over to showing the peaks found by the viewer and then actually go in here. These are exactly the same numbers that you type into the Cheetah peak finding. Okay? Just comes up with a few options here. And you can sit here and quite happily go, okay, let's make sure that everything's over 250 ADU with 2 pixels up to 20 pixels with a signal to noise ratio of, let's say, 6. What happens there? It goes away and thinks for a minute, and then, okay, the graphics are a bit slow to update, but then it'll apply those peak finding criteria here, and you can say, is it better or is it worse? Shuffle through the images. Evidently it's not doing a lot there for some reason. And you can sort of tweak up the parameters that you should be putting back into the .ini file. Okay. It's kind of good because it gives you instant-ish feedback on what your peak findings are. Okay? Finished, submitted. Run 9 should actually be running. Okay, someone maybe went over the top of things there. Okay? So that's that.